So what I want you to do is I want you to pick one value of X to be a predictor, and then another value to be the response variable. So for instance, one of my values could be median income. Median family income is probably going to be my Y variable. So you just select all that. Now what you want to do is you want to select it up to the top of the data. You don't want to pick any non-numeric data. It's just going to be data. And then you're going to paste it into StatDisk. So let me paste it in column 2 maybe. And then I'm going to pick a value for Y, or excuse me, a value for X, some kind of explanatory variable. What explains how much money you make? Well, let's go back to our data set. And since I'm a teacher, maybe I value education. And let's look at something from education. Maybe some college. How well do people with some college fare? I mean, how well of a predictor is that? So I'll grab this column. And again, just grab the numerical part. Don't grab any headings. Don't grab any spaces. If you grab a space here, StatDisk isn't going to like it. So just grab exactly your data. Copy that. And let's paste that into StatDisk as well. I'll put that in column 1. So I'll go up here at the top, paste that in. So now I got 2 columns of data. The first column is where I expect the X's, and the second column is where I expect the Y's. So let's go to analysis, correlation and regression. We can leave it at the 5% level. My X's are going to be in column 1. My Y is going to be in column 2, and then click evaluate. Now, there's several things that I would look at here. First of all, I'd probably look at the scatter plot. And surprisingly, there's a negative relationship here, right? If you take a look at this least squares line, as you increase the percentage of people with some college, median family income drops. Wow. Can anyone explain that? What do you think's going on here? I'll tell you what, since we've got a limited time left, I'll explain it. What's going on is that if you have a median family, or excuse me, if you have some college, the higher percentage of people with some college means the lower percentage of people with bachelor's, master's, and professional degrees. And you're kind of limiting yourself if you have some college. I would guess that if we did the same kind of plot with people who had bachelor's degrees or bachelor's or higher, that you get a positive relationship. But you get a negative relationship here, so that's kind of interesting. It's saying that some college is good, but you need more than some college. You want to finish that degree. Now, the equation here is 152,048 plus negative 2,029x. So let me write that down here. So we'll do m equals negative 2629x plus 152,048. So that's our regression equation. And what it says is that for each additional percentage point of people with some college, median family income drops by $2,629 per year. Okay, so there's a negative correlation, which is a little bit surprising, but not too surprising. I think that overall, education is a good thing to have. And this isn't saying otherwise. It's just saying you don't want to stop halfway through. You want to finish off that bachelor's or master's or professional degree. What else do we need here? Coefficient of determination is 0.48. That's pretty good. That's pretty good for just one variable to explain almost half of the variability in a data set. That's not bad. Our p-value was 0, meaning we got a significant regression. And the value of r, where is it? Value of r basically says we got a negative relationship, which is what we saw when we looked at the scatter plot. I don't think I asked you for r in the homework, but you could use r in coming up with your, or to correlate with the slope of the data that you see here. They're both negative, so that makes sense. Any comments or questions on this? Does that help out a little bit there?
Yes, I think so.
Okay. Anything else?
Did you say you'll post this on YouTube?
Yes, yes, okay. I will.
Thank you.
So a little bit more about part 6 here. It says, do you think your model explains a reasonable portion of variability in Y? What I want you to look at is R squared. I mean, if your value of R squared is like 17%, 0.17, that's not explaining a lot of the variability in Y. I know that in this data set that I get a value of R squared of over 60% for one of the variables that I chose for X. So you can do actually really well in explaining the variability in Y. But, you know, maybe yours does, maybe yours doesn't. Look at the graph, look at the equation, and see if you think that the value of X does a pretty good job of explaining the value of Y. Like right here for this roller coaster data, let me put back in max height here. You can see by the graph that the data is pretty close to the line. So that makes you feel good right there. And you feel even better when you look at the value of R squared and see that that's 0.79. I think if I remember right, drop gives us a little bit better. Yeah, there we go. Almost 0.84 if you just look at the drop instead of the max height. That's a really tight line. You're doing a great job of explaining the variability in Y by looking at the variability, or by looking at the value of X. So between the plot and the value of R squared, just give kind of a subjective statement as to whether or not you think that it's a good regression. That's all. So that's what I'm looking for in number 6. So does that answer your question there? Does that help out a little bit?
Yeah, it does. Yeah.
Okay. Thank you for that. All right. We'll call it a day here, and good luck with the homework. If you have any other questions, let me know.